Formulation of theories and laws in science. Theory is an organized set of reasoned ideas intended to explain fact, phenomena, and events. It represents a coherent explanation of the crux of one or more hypotheses. It fits best to the known fact and remains valid so long as solid evidence are absent to dispute or disprove it. Thus, theories are more accurate and stable than hypotheses. However, they too are liable to falsification. An accepted theory may be revised or rejected whenever opposing evidence are adduced against it. Since scientific investigation is an ongoing process, theories may be subjected to revision from time to time to bring them into conformity with the new findings. Some of the criteria for the validity or acceptability of a theory. 1. The theory must be logical, rational, without ambiguity. 2. Conformity with the existing observation and experimental evidence. 3. Empirical or experimental falsibility. 4. Relevance, usefulness, and effectiveness in explaining facts and solving problems. Fifth one is capability of making predictions. And the last point is explicit explainability. Scientific law or principle is a universal applicable or universally accepted theory with the capabilities for making true predictions. A law and a theory share several common features. Both are widely accepted, rational, and relevant, empirically testable, and liable to revision or rejection. A law is often consists summary of a large number of facts, whereas a theory is a generalization which explains those facts. Unlike a theory, a law can be expressed in the form of a single statement or in the form of a mathematical equation. A law states what is nature doing under certain conditions and predict what will happen so long as those conditions are satisfied. On the other hand, a theory explains how nature works. Scientific evidence. Evidence are the fact and figure used to support, oppose, substantiate, or invalidate a hypothesis, theory, or law. In scientific investigation, evidence are collected either through direct experience and observation or through experiments. Thus, scientific evidence need to be empirical, testable, and collected by scientific methods. These evidence are systematically arranged and scientifically analyzed and applied to the field to investigation. They may either comply with the proposed hypothesis or theory, or contradict its prediction. Based on this result, the hypothesis or theory is accepted or rejected. Scientific proof. Proof is a logical deduction or a process of reasoning applied to establish the truth of a proposition or an assertion. It is usually based on accepted assumption on proved inference. Arguments must be true and based on an established fact, otherwise the result will be an error. Known as circular evidence. A proof which establishes the truth of the thesis is called simple proof, and The one which exposes and establishes the falsity of the thesis is called refutation. In scientific investigation, the relevance of proof is doubtful. Often, the term proof is wrongly used in place of evidence. Strictly, it cannot be used in science in the same sense as it is used in mathematical or logic. Proofs have two features which do not actually exist in science. 1. Proofs are final. 2. They are binary with two possibilities, namely true or false. Development of a simple theory by scientific method.